In this video, we're going to look at margin of error and confidence intervals. And to me, this is one of the most important ideas of this course. We're meeting a major goal of using a sample to make an assertion about the population. And that's what we're going to end up doing with our confidence interval. So we know our samples are going to have some variation to them. The sample isn't always going to match the population perfectly. The sample could be a little bit too high above the population. It could be a little bit too low below the population, even when our sampling is done correctly. So we need to take this into account some way, and we do that with the margin of error. So the margin of error has this formula, and it's very similar to the standard error formula. It starts with this ZC out front. This is a Z critical value. And this depends on your confidence level, which is going to be given to you. You might be 99% confident, 95% confident, 90% confident, or 80% confident. Depending on the level that you're given, you'll use one of these four values. This is something you need to know for our next test and for the final. So it leads with one of these numbers, and then it's the square root of p hat, 1 minus p hat over n. This part is like the standard error, but it uses p hat instead of p. You can type this into your calculator all at once. Now, what these levels of confidence tell us is how confident we can be in our assertion. For example, with a 95% confidence interval, we can be 95% confident that our methods have calculated the correct population number. But we're not 100% confident. 5% is left over. It's expected that 5% of all of these 95% confidences will not capture the population proportion. So we can't be guaranteed that we have the exact right answer. With a 99% confidence level, 1% of those confidence intervals will not calculate the population proportion. To dig further into the idea of confidence intervals, as we said, it's one way to use statistical inference, to use a sample to make an assertion, to make a conjecture about a population parameter. There are 4 steps to follow if you're going to find a confidence interval by hand. Step 1 is to find p hat. You do that by taking your successes and dividing by the sample size. Then you check the normality criteria. In step 2, that's the central limit theorem. You find the margin of error from the formula up above, and then you put it into confidence interval notation. You take your p hat from step 1, you subtract e, that's your margin of error from step 3. That gives you your lower bound. Then you take p hat from step 1, you add that same number, that same margin of error from step 3, and that gives you your upper bound. To give you a full example going through all the steps, let's say we've got a science fiction website and they announce that 46% of all college students believe that extraterrestrials have visited our planet. Now, that's a very broad claim. I mean, they're saying P is equal to 0.46 because that's for all college students, for every single college student on the planet. Now, I highly doubt that this website was able to talk to every single college student So we want to investigate this. We randomly select 250 college students. So in our sample size is 250. You find that 45 say, yes, I believe that aliens have visited our planet. We want to construct a 95% confidence interval to investigate the true population proportion. So we're going to use this sample of 250 to make an assertion about the millions and millions of college students all over the planet and whether or not they believe extraterrestrials have visited our planet. So N is 250. My success number, or those who said yes to my question, I believe aliens have visited our planet, is 45. It says right here, you find that 45 say yes, I believe extraterrestrials have visited our planet. So that can get me step one. To find p hat, I can take my success number, 45, and divide by 250. And that gives me 0.18 or 18%. So right then and there, this original claim looks suspicious. 18% is a lot lower than 46%. But I know there is room for variation, so I need to proceed. The next sample I get might be 32%, so it might be even closer to the 46%. For my second step, I want to check the central limit theorem. 3 things to check. Number 1 is that a random sample, I can say that is met because it says you randomly selected 250 college students. My success number is equal to 45 over 10, so it's met. And my failure number has to be 205. It's over 10, it's met. Again, I know my success number and my failure number have to add to be the sample size of 250. You can just take your 250, take away your 45, and that gives you 205. I can't use N times P for a few reasons. Reason number 1, most of the time you aren't given what P is. That's the whole purpose of statistics. You don't know P, the population proportion, so you use P hat, the sample proportion. Reason number 2, I'm highly suspicious of this 46% from this sci-fi website. So I don't know if I want to use their information. It may not be valid. So it's okay to use your actual number of yeses and nos to get your successes and failures. For my third step, I want to find my margin of error, that's E. And I'm going to use the formula from the top of this page of notes. It starts with a Z critical value. So for 95%, the Z critical value was 1.96. So the table at the top of this page. Then it was the square root, so I hit second x squared, and it used P hat, that number from step 1. So it's going to be 0.18. The formula was parentheses 1 minus P hat, so parentheses 1 minus 0.18. We close those up and then divide by the sample size, which was 250. So I get 0.048. That's my margin of error. I'm going to use that in this final step to calculate my confidence interval. I take P hat and subtract that margin of error. That's going to give me my lower number. I'm going to put this in interval notation. So I'm going to take 0.18 as P hat, subtract 0.048. And that gives me 0.132, comma. Now I'm just going to add those same 2 numbers. and I get 0.228. So this tells me something very important. It tells me if somehow I were able to talk to every single college student on the planet and ask them, do you believe extraterrestrials have visited our planet? I can be 95% confident that somewhere between 13.2% and 22.8% would say yes. This 46% seems way too high. I think it's about 13% to about 23%, somewhere in there. That's my range of possibilities, and I'm 95% sure about that. Confidence intervals can be difficult the first time you see them. We're going to continue on with these in the next video.